Let me introduce Wallace, who's going to be talking today about building information modeling. Now, BIM, as it's known, is going to be a key factor in architectural, structural, any architectural science work is going to increasingly use BIM. So Wallace has been doing some work with BIM here at the school, and particularly in the hospital sector. So I'll pass it over to Wallace, but next week we are going cultural. We've got Maori Kepa will be presenting on the Maori worldview and the cultural identity and how we can actually incorporate that into our buildings. So anyway, over to you, Wallace.
All right, thanks, Regan. I'm Becky for inviting me to give this talk. I just jump right into the slides. All right, afternoon, everyone, and thanks for joining in. My name is Wallace. I'll be giving this talk on building information modeling and some of the impacts on healthcare facilities. We did this project over the summer, so it was a summer 3 months research project. All right, so just working with me, I had several team members. I had Jacqueline. She's an expert in design of institution for special needs and also in terms of mental health designs and building layouts, and also Regan as well, who is into structural engineering. I also had Aidan and George working as research assistants on this project. Okay, so I just touched briefly on the changing BIM paradigm and what is happening currently within the industry. Just the idea of having all your building information, because BIM represents a shared data within the building envelope. So you have several models from different consultants coming into one federated model. And this will continue to see a rise in this trend. Currently in the latest EBOS report in New Zealand, you can also see this shift towards more use of BIM in the industry. Then towards the right, the figure on the right, just a screenshot of some of the tools, some of the BIM tools. So you may start asking yourself, for those who are in construction space and also within facilities managers, just wondering how much or how many of these tools you currently apply, and if not, so it now will be the right time for you to get on board this BIM paradigm shift. I also highlighted some of the tools that will be covered later on within this presentation. We'll be using Revit, Autodesk Revit for authoring, and also Autodesk Recap for registering our LiDAR scans. Then we also use Fuso. This is for more virtual reality simulations. And we also made use of HMDs, head-mounted devices as well. Then within the trend, just looking at how far building maintenance systems have come along the line. So we can see that things are quickly quite moving rapidly within the industry. And now we have looking towards AI and also robots and use of drones. Okay, so I just to capture some of my research background. So within the past 2 to 3 years, I've also looked at using drones on construction sites. This is the top figure here. So within the projects, we're trying to identify areas for improvement in terms of material use, safety monitoring as well, then also material storage, and also mostly on safe habits on site. So with this, we can do real-time updates and also inform the safety officers to take adequate precautions. On the bottom figure, I also did some work, doing some work as well in the Malaysian My Carbon reduction tool. So we're trying to look at how we can automate this process for the industry. To the right, this figure, I did some previous research around automated building code checking. So I had a research assistant go in and look at some of the building consents and the clauses in the building code in New Zealand. So we had this BIM, so it's an automated system for New Zealand where for new projects to get consent, you submit a BIM model to the local council, and within the consenting office, they would run your BIM model through this system. So in this example, you could see that within the circulation space, so if we look at the clauses covering circulation, so the system read a smaller section of the circulation space instead of the larger width within this, close to this entrance. Yeah, so these were some of our findings, and we did some recommendations to the back-end programming for the system. All right, previous summer, I also was engaged with Heritage New Zealand, where we looked at the old government building. So this is just covering around remodeling heritage buildings through photogrammetry. We also applied LiDAR scanning to the interior spaces. So here at the bottom left, you can see the interior space, just the sheer size of this roofing space with lots of HVAC systems going through. Then we also flew a drone over the roof.
Wallace, can I interrupt just for a moment? Because we're not seeing anything of what,
we're not seeing what you're seeing.
You're talking about. We're seeing the speaker notes for the PowerPoint, not what you're actually talking about.
Mm. Oh, okay. Let me see, one moment. Is it visible now?
Yes.
Okay. So just restart again. All right, so just the project teams that I covered earlier, and also the BIM tools and the BIM paradigm, and also the previous research as well. Okay, so just for the roof, we had thermal imagery, thermal camera with the drone to capture possible areas for leaks within the roof and come up with maintenance procedures to facilitate repairs to these sections. And also we looked at the moisture as well, moisture content within the roof. Okay, so another research which I was quite keen to get involved with is just analyzing Courtyard Systems. So this is the Shenyang Courtyard system in China. So within this space, we are looking to improve and put in green sustainability features within the space. And I also do some work around virtual reality as well. And recently during the pandemic, I also got involved with the research team all the way from Indonesia, Saudi Arabia, Japan, and also in Nigeria to analyze the impacts of COVID, most especially on the well-being of students moving with this sudden shift to online learning. All right, so for hospital facilities, since facilities management covers quite a wide spectrum, so our main focus would be towards space management and also to a larger extent, maintenance and asset management. Just knowing fully well that for facilities, it covers about 87% of operations. And the figure below here just tells you how much the importance of BIM plays within operations and maintenance phase. So if we look at traditional handover process, so when upon completion, documents are transferred to operation and maintenance team. So we tend to see a drop in the information suitability when compared to using BIM information. So with BIM, you can hand over as built data right on to the facilities management team. All right, so when we came into this project, so some of our observations, because at the time we started this project, the FM team were concerned about a new project coming up, a new wing to the hospital. So they were concerned about having, merging their old buildings with the new buildings coming up. So we had to come up with a framework, an integration framework where we could link in all the buildings within the hospital. So we have that within the hospital, they had manual data entries, which were not so efficient. Then also readily access to relevant data was quite slow. And also in terms of how data was captured, then all their systems were based on separate platforms. Then we had also a sort of a lack of integration between several departments, and also just thinking of around a long-term strategic plan for development within the hospital. All right, so the figure on the left was part of our observation. So within technology use, they had BIMs, which covered asset management, BAS, some automation systems for maintenance, and also using Excel spreadsheets for space planning. Within the office, they also had huge, large paper drawings, which we really wanted to have in a digital format, in a BIM format. So that's a representation of the buildings below. So we came up with this integration framework in terms of just looking at the departments and how separated each of these departments carrying out their functions. So we try to recommend merging all the buildings informations into a BIM 3D model. So from this space, we can start to use things like Kobe or other softwares as well to have the ability to view this building model for each block. And these blocks contain both clinical and non-clinical services. Okay, so we went on to do a wayfinding analysis as well, because there was the issue of patients missing their appointments or getting lost within the building, and people asking lots of information. So this was quite impossible to do easily within 2D models. So thanks to BIM, we're able to carry out this analysis smoothly. So some of the ideas we brainstormed were moving all services within the ground floor to floors above, and leaving floors on the ground, spaces on the ground floor, would turn them into commercial spaces, which could also be rented out, and you could also be a source of alternative revenue to the hospital. Some other things we brainstormed about was having color codings to have linking adjacent spaces. Then we also looked at the signage system as well, in terms of improving signage for people to easily get around the hospital. Then we also worked with my colleagues up at the computer center with Valera and Anarup, and Jesse also did his final year project on developing a wayfinding apps. So within these apps, you could get an alert systems, an alert information for your appointment. Then it's easy for you to set up a wayfinding route once you get into within the entrance of the hospital. This was quite new for us, so quite a good learning experience in terms of dealing with indoor navigation systems for buildings. All right, so just looking at changes to space, because the FM team wanted to have a long-term strategic plan in terms of how they made changes to spaces and moved offices around, and also occupants around the hospital. So we focused part of this research. So we presented two strategies, activity-based working, and also we presented biophilic design. So for biophilic, probably Becky will invite me again to discuss about biophilic solutions. But in this presentation, I'll just cover activity-based working. So activity-based focuses on creating spaces with a wide variety of activities. So ideally, the focus shifts from your business focus to the individual. So in terms of just the individual well-being and making your workers more creative. So within the activity-based working, workers choose their workplace settings themselves. And so there's high flexibility around the spaces you create. And also you need to have the ability to have printing options available within the spaces, and also tie it into the business culture. Some of the disadvantages of where people have disputed activity-based is it tend to have ignored spaces, yeah, and also within, if you had sensitive workplace functions, so that could lead to some other issues as well in terms of business culture. Then other issues, features of activity-based is you have social spaces, formal meeting rooms, informal meeting rooms, and also flexible workstations. Okay, so we carried out 3 case studies just to get an insight into activity-based studies to come up with our design solution for the hospital space. So we looked at the Spark Central. So this building, so from the previous research, it found that about 45% of the users change their space, their usage every other day. So this was quite interesting because this was what we would like, a future we would like to see within an activity-based working environment, to have occupants moving around the space. So here you can see how the spaces open up to the atrium, and you have natural light coming in. So it gives you that a good feeling. Yeah. Then we also had the issue around behavior as well. So behavior was quite important in understanding how these spaces were used. All right, we also covered the second case study, was a TVNZ refurbishment. So here, the main goal was to make it open and alive. Yeah? So we could see that the spaces had giant monitors. And if you look at this figure here, you could see the mural on the wall, which covers some of the cultural Maori features, which is quite interesting of how we could incorporate some of these features within a space. And also there were different, the figure below, different sitting informal spaces where staffs could move around and feel alive. Yeah. And there was also strong visual cues in terms of moving from one space to the other. All right, so we also checked on Macquarie Bank. This was a building in Australia. So one key feature within this case study was the ability to give you visual cues to differentiate between different spaces. So here you can see the color codings on the floor. So from both the furnitures and the finishes on the carpet. So this transcends, just gives you some cues on how you could move around the space. Then one other key feature we found was they could mimic lots of spaces. In this example, there was a mimicry of restaurants. So just having the ability to leave your traditional workspace and moving into another space that mimics you being within the restaurant. Yeah, so this was a very good feature. Then it was also easy to navigate as well. All right, so we analyzed based on the workspace variety and visual connections within those spaces, and also the space differentiation, and also the ability to have space flexibility. So we assigned some scores within the range of 1 to 10. So the bank had the highest average, which was about 9. So here we can see some of what they used within the bank and how they did the color codings and also furniture arrangements as well. All right, so when we went on site, we used the LiDAR scanner. So there's a Leica BLK 360. So we use this to capture point cloud data. So this image here represents the point cloud scan. So this was done for 4 floors, from the 10th floor to the 13th floor. So then we now went on to build on a Revit model. Then this was then transferred into Fuser, where we're able to work on the design changes within the virtual reality space. Yeah, so the figures here represent the current model and also our design solutions for the facilities management team. So another key feature of capturing this data, the BLK comes with real-time cameras. So here is the camera of a real-time space, of how the space looks like. Okay, so some of the findings we found that there were a lack of visual connection between the spaces. So here we just focus on the 12th floor. So in this example, you can see that due to the walls within the corridors, you can see that there's less light coming into the spaces. And also there's also a limit to circulation. Then also office densities. We found that in some spaces we had more workers in some spaces, while in some spaces we had less usage of space. So the facilities management team wanted to have more workspace and fit in more individuals per square meter. Then it was quite difficult to distinguish each workspace from your traditional workspace system. All furnitures looked alike, all finishes to the floors and walls, they all looked alike. So this was quite poor. Then also we had a low ceiling height as well. So unfortunately we couldn't scan the HVAC systems, but we were able to use the markings within the point cloud to locate things like fire sprinklers. All right, so we now did a mapping of, we compared what the results we had with our previous case studies. So we can see that for the healthcare facilities, it's scored quite poor, an average of about 4 compared to other case studies. Yeah, so the ideal we were looking at was the bank layout. So we found that within the 12th floor, it was about 12 square meter per person. All right, so in our design solutions, we tried to do away with some of the internal walls, and also in terms of space configurations as well. And we had to increase the number of toilets and the locations of those toilets. Initially, in the initial floor plate, you had the toilets just at the entrance after you exit the elevators. Then there was also the need to create storage facilities as well, because you had workers coming in with bags, and the office space was not so tidy. So just to make it nice and neat, we created storage, then also created a very nice reception area. Then also we increased the workspace from about 80 to about 100. Yeah, so we get more value for your square meters, your space. And we also used some exposed ceiling as well. So you could, in terms of if there was an earthquake, yeah, so we considered some of those features in terms of ceilings and ceiling coming down on individuals. All right, so this is a snapshot of the design solution. And so in the initial plan, around this corner, we had the kitchen. So just having that social space meant that everybody in their offices had to walk quite a long distance to get to the kitchen. And we also observed that while during our data capture, we had other staffs coming in from different floors to that same kitchen. So we're able to relocate that to a more central location. So just to get people interacting within a central space. And we also use some of the features of color codings as well to differentiate between spaces. All right, so we created various workspace alternatives for people to work within groups of tools or individual workspaces, and also provided alternative to the furnitures as well. So you could have standing options and also sitting in terms of just your ergonomics and understanding the impact on the health and well-being. Then we had this kitchens as well, then other social spaces. Then we also had quiet meeting rooms. Yeah, so all these are sealed spaces in case you wanted to discuss something confidential. So some of the feedback we got from the FM team was we could use more executive chairs for these spaces for the conference rooms. All right, so just moving on to some of the applications of having a BIM model. So earlier in the presentation, I showed some of the ease of usefulness of having to analyze wayfinding, just having the BIM model alone. If you have the BIM model, in this example, you could have a walkthrough within spaces, just in terms of maintenance. So you could capture using 360 images, you could capture issues within the facilities. In this example, I just put in a markup of having issues with electrical contractor. So you could easily mark up in real time using this sorts of tools on your BIM model. And also, there's a similar previous research from Ahmad. You could also create layers within your LiDAR scans and embed maintenance informations, and in terms of timeliness of maintenance and maintenance schedules, you could create layers and impute this information within your LiDAR scans. Also, just looking at the current advances in blockchain and the need for having smart contracts. These BIM models could help the facilities management team to negotiate contracting jobs with contractors in terms of price suitability and also document consistency, because currently there's lots of refurbishments to different parts of the spaces that the 2D drawings they have are not really up to date, so they are not as built, and this could also lead to issues of rework and some added cost for them as well. And also dealing with interdisciplinary coordination in case you wanted to do some works which involves several consultants as well. Then also in terms of cost, so the facilities management team could, just using this BIM model, have beforehand some idea of cost implications for retrofitting within those spaces. All right, so I'd just like to end this presentation with a short video since I've been speaking. So I'll just give you an idea of what we did, presented to the FM team in virtual reality. So they used the HMDs to view the spaces. All right. I think that's all from my end. So I'll just pass it back to Regan for any questions.
Thank you very much, Wallace. Yes, we're tight for time, but are there any questions? Where are we?
Yeah, obviously there are some interesting COVID-19 implications to the design that you've got there, but that will be a problem for the future. I was interested in something from the very beginning, that the app to Wayfind seems to be an ongoing problem as buildings get more and more complex. Did you actually take that to practice, or was that just a conceptual?
Oh, okay. We came up with a prototype. So we had to test using indoor beacons. So that was quite tricky because we had to figure out how to link when you are moving between floors. So that was a bit tricky. So for wayfinding on a flat GIS surface was quite different from how you needed to move from one floor to the other. So that was where we had some issues. But in the test run, it was quite okay. And we're looking forward to developing it further.
Any other questions? Wallace, I've got one that I know from the work that we did that it was incredibly fast to generate the BIM models from the scanned data.
Yeah.
How's that developed?
Okay, this scanning was quite fast. We had over 300 scans, about 80 scan positions per floor, because we needed to keep a distance of about 4 to 6 meters between the scanning locations. But developing the BIM model took it was quite fast, because once you had one floor, it was a matter of copying to the next floor. So those were, so within 2 to 3 weeks, I would say you could come up with such BIM models.
Any last question for Wallace before we disappear from our virtual atrium?
There's a question in the chat list.
Oh, is there? Let's have a look. So yeah, Wallace, what's your method to validate your data from the BIM models to come out with the Kobe format? How have you done the accuracy for your BIM data before integration with any FM facility management system or tools?
Okay, validating the BIM data. So this was quite difficult, because we had to think of in terms of accuracy of the scans, because part of the challenges we faced was that previous drawings, because earlier we tried to build the BIM model out of the 2D floor plans, but this was not really accurate. Before we now decided to go in and use the LiDAR scan to capture as built data. But from extraction into a sample Kobe sheet, I didn't really put it up in the presentation. We had, it pretty much captured most of the building objects and elements. And also we see that it will be easier to do space planning and capturing and tagging all the spaces within the BIM model.
Okay, folks. Well, thank you very much for joining us today in the atrium. Next week, and thank you very much, Wallace. Next week,
thanks for having me.
Mari on Maori identity and disaster. But let's just give a virtual applause for Wallace. Thank you very much, Wallace. Much appreciated.
All right.